Hello and welcome to our video presentation. We would first like to thank Dr. Vergara, an Associate Professor of Industrial and Manufacturing Engineering at Oregon State, for allowing our team to use his activity format for our demonstration of production system design. Today we will be doing an activity about production system design. Production system design is when you take a manufacturing system and tweak it a little to test for improvements in the process. Typically, this is done by an industrial or manufacturing engineer to decrease the amount of time it takes to make a part, therefore increasing the efficiency. The purpose of this activity is to gain experience in collecting data and evaluating the performance of a queuing system in a manual production system. Each group will have 4 to 5 people, with each person serving one role. We will be going over 3 iterations of this activity to show how process improvement is achieved. For the first iteration of this activity, the workshop will be presented like this. At workstation 1, we will have an assembler picking up a bag from the beginning of the assembly line and opening it. 5 pink beads will be placed in the bag, followed by 5 blue beads. Then, the assembler will measure out 12 inches of elastic string and place that in the bag and close it. The bag will be placed at the end of the queue before workstation 2. This workstation will remain the same for all 3 iterations of this experiment. Observer 1 will record the times when a bag arrives to the queue at workstation 2. At workstation 2, we will have an assembler taking a bag from the queue and placing the contents in bin 1. They will be placing beads onto the elastic string by alternating colors, tying 3 knots, then closing the bag and placing it into the output bin. Observer 2 will be recording when bags are taken from queue 2, and Observer 3 will record the status of workstation 2. The status can be anything from the queue to how the operators seem to be working. Are they rushing? Are they slowing down? This activity will last 180 seconds, or 3 minutes. After iteration 1 is complete, you should have noticed from your observation that the number of bags station 1 is able to complete is more than the number of bags station 2 is able to complete. This will result in a buildup of incomplete parts in the queue. At this point, you may ask, how can the system be improved so that there are less parts in the queue and work does not go wasted? A few suggestions that may be made are the following. Adding workers to Station 2, splitting up the work, allowing operators to move between stations to balance out the work, also known as flexing, or introducing new tools to aid operators in the process, such as a holder to make it easier to string beads or a machine that will do it for them. After discussing these strategies, you may move on to iteration 2. For the second iteration of this activity, the workstation will be presented like this. Workstation 1 will be the same as the previous setup, however, there will not be an observer for this station as it will not change. Workstation 2 is identical to the previous setup, however, there will now be 2 operators from this station. Each assembler will be taking a bag from the queue and placing their completed workpiece into the output bin as they complete it. Observer 3 will be recording what bags are taken from queue 2, and Observer 3 records the status of workstation 2. If your group only has 4 members, and Observer 3 is not necessary. This activity will last 180 seconds or 3 minutes. After iteration 2 is complete, you should have noticed from your observations that the number of bags in the station 2 queue has been reduced. The output from the station should have also been increased. At this point, you may ask, are there any other improvements that could be made, or would a different change have made it better than this iteration, and why? After discussing these strategies, you may move on to iteration 3. For the third iteration of this activity, the workstation will be presented like this. Workstation 1 will be the same as the previous setup. Workstation 2 has now been split into 2 separate workstations. At workstation 2, the operator will be taking a bag from the queue, opening it, and placing the contents into the bin. Each bead will be placed on the string alternating in color. The operator will then pick up a tool from the tool bin, in this case a binder clip, and use it to clip the string together. They will then place the part back into the bag and place it at the end of the queue before workstation 3. Workstation 3 will have 1 operator completing this process. They will take the bag from the queue, remove the part, and tie 3 knots on the string, completing the bracelet. Then they will return the part to the bag and place it into the output bin, or the completed goods bin. Observer 2 will be recording when bags are taken from queue 2 and when bags are placed into queue 3. This activity will last 180 seconds or 3 minutes. After iteration 3 is complete, you'll notice that the queue between station 1 and station 2 is longer than the queue between station 2 and station 3. Operator 3 is often left waiting for work as the new tool impedes the second operator's time. Why does this happen? Upon further observations, you may discover that the tools provided are not helpful because the most amount of time spent at this step is not tying the string but placing the beads on. The conclusion of this activity is that iteration 2 is the best setup. This is because adding a second operator to workstation 2 allows for the shortest queue and the most number of completed pieces to go through. This concludes our video activity presentation. Thank you for watching our demonstration and for your interest in our project.